So today we will discuss photoelectric effect, and we will determine Planck constant and work function of the material. From this experiment, we will determine two things. One is Planck constant, another is work function of the material. Right? So based on the experiment of photoelectric effect. Now this is something underlying theory that you know or you will learn in your theory class. Dr. Sahu will discuss that inside the material, the electron is there and they are free to move. But if you want to remove the electron from the material, then you need some extra energy, or you have to done some work so that it can release from the material and it can escape from the material. Then we can say that the effect is if it is applied due to the application of light, that is photon, then the phenomena is known as photoelectric effect. So ejecting electron with the application of photon, that is photoelectric effect. So now you consider the electron is present inside material. Now we say it is present in a potential well. Right? We can say that it is present in a potential well of energy E into phi. Potential well of energy E into phi. So this is the energy. So if we remove it, that is, if we remove from the metal to outside, then we have to apply some energy which is equal to E into phi. This is negative. So we have to apply some energy E phi so that energy, total energy sum will be 0, then it can escape. But if it is 0 total energy, then it can release from the material. But what is its kinetic energy? Right? So that means if we apply some external energy with the application of photon, which is greater than this energy, then it can remove from the material, and the same amount of energy, positive energy, will apply to remove it, and then the remaining part will be used to give its kinetic energy. Now, this is the if we consider the kinetic energy of the electron, then we can say which is equal to half mv max square, that is equal to h nu minus c phi. So kinetic energy, that is half mv square, that is equal to h nu minus c phi, where h nu is the energy of the photon. This photon will collide with the electron, and it will it gives its total energy to the electron. Then it will knock out from the material, and when it is knocked out, then its kinetic energy is this. That means its supply energy by the photon, that is equal to half mv square plus c phi. So this C phi will utilize to escape from the material, and remaining part will utilize to give it the kinetic energy. Now this equation can be written as like this: half mv square, that is, we can write it into E v naught, and this is h nu minus E phi. Right? So this v naught this V naught, that is H by E nu minus phi. So based on this relation, we will calculate the value of H and phi. Now this can be considered as, if we consider that is y equal to mx plus c, this equation, y equal to mx plus c. So m is this, H by E, and c is this, right? Then you see, if we apply this voltage, or we can say in terms of this energy is converted into EV, that is the voltage. So we can say, if we plot the current, suppose now you come to the experiment. There is a high tension, it is applied between these two electrodes, and a light beam of suitable energy, that is H nu. Nu is the frequency of this light beam. Then what will happen? It will knock out the electron, and due to this application of this potential difference, it will accelerate towards this, and it will be collected. Right? Now, we are changing this voltage. Then what will happen? This electron, the collection of this electron will increase. Right? Suppose this voltage is low volt. Then this is the number of electron it is collected, and that will contribute the photon. Then after certain value of voltage, then your current is saturation. That means all the knockout electrons are collected. But in this region, all the knockout electrons are not collected because their velocity is not sufficient, so that this potential, within this potential, it cannot be collected. Right? So they will recombine some. Right? So it can be collected with some specified potential. If we apply, then all will be collected, and your current will be in saturation. Now, if we apply this voltage in the negative direction, then what will happen? When your voltage is 0, then also we can get some current. It is also collected some electron, because the electron which are ejected from this, it has its kinetic energy. With this kinetic energy, it can reach up to this electron. That is, electron will reach to this electron, and that will contribute in the photocurrent. But if we consider that voltage is negative, so it will repel in opposite direction, right? It will repel, and when it will repel, that means all the electrons which are ejected are not collected, right? And if we increase this negative voltage in some region, then it will stop the photocurrent. That means it will repel all the electron and no electron will be collected. So it will stop. Now we are interested basically in this region, right? So here, this, if we consider this region, this portion is equal to phi minus phi, and if we calculate the slope of this, then slope is H by E. That we need to calculate the slope and this region, cut of this region, that is phi and H by E. From this result, we will calculate the Planck constant and work function. Then we will calculate the work function of the material, right? Now, this is the same things that I have already mentioned. This indicates the stopping potential. This particular value of voltage is known as the stopping potential, right? So it will stop the photocurrent. Right? So basically, we are interested for this region. Now, this is the experimental arrangement. If you come in the laboratory, then you can see. Here we can measure the photocurrent and we will apply some high tensile voltage by changing this, right? And this is the lamp. Inside this reactor and vacuum tube both are present, and here that two electrodes, in between these two electrodes, that will be electron will be ejected and collected, right? And this is the that light source or photon that will hit on that electrode, like these things. Now in virtual lab, so this is, we can measure the current and we are applying the potential, so we can take the reading of the potential as well as current. This is the source, so light will fall through this, and this is the material, and in between there are two electrodes. The light will fall in one electrode and other electrode is within negative potential. It is connected, and then we will measure the potential and photocurrent. This photocurrent and potential we will measure. Right? So this is the experimental link. So first, from this control panel, we have to select that all of you know. First, you have to choose the material, copper, sodium, zinc, these are the material. Then first you take copper, then plate area, right? You can change it. Then intensity of the light, right? Voltage, you have to change, and wavelength of the light. And switch on, then you will start your experiment. For a typical value, you can also change the area 0.3 centimeter square or other value, maybe 2-3 different area you have to consider and you have to perform. At the same time, you have to also vary the intensity of the light, and with the variation of voltage, you have to calculate the current. You also fix your wavelength. Now, you have to write a particular wavelength, for which wavelength you are considering. Then color of that wavelength, So you have to take different sets of reading for this. Now IV characteristics. Now you need to change the voltage and you note down the current. That is voltage versus current, right? Then from that you have to calculate the stopping potential wavelength. For this particular wavelength, you are changing your voltage when current will be 0. That particular voltage you have to note down and corresponding wavelength. Then different sets you have to take. Now then you have to plot frequency and stopping potential. Frequency and stopping potential. If you know the wavelength, then from that wavelength you can calculate the frequency, that you know. So this is frequency and this is stopping potential. Suppose for each one you have calculated the stopping potential, right? For particular frequency. For particular color, for a particular color, or we can say different wavelength, you have to choose. Then by varying this, you can calculate the stopping potential. For one color, stopping potential is this. So that is one set of data. Another, you have changed your color, then you have calculated the stopping potential. This is another data set. And like this way, you have to plot. That is the frequency and stopping potential, right? Then,
Sir, can you repeat that part?
to plot it, you need frequency and stopping potential. So how you will do? According to this table, you see stopping potential and wavelength. For a particular wavelength, you will calculate the stopping potential, right? Then you change the wavelength and again you calculate the stopping potential, right? Like this way. You have to complete this table and that is your data set. And to calculate the stopping potential, here you change your voltage and corresponding current you note down. Then you see for which voltage it is current is 0. That is the stopping potential. So that voltage and the corresponding wavelength you will note down. Then again you change the wavelength, right? Again you change the wavelength and then you repeat this table. That is voltage versus current. When current will be 0, that particular voltage you put it here for a particular that wavelength. Then again you change wavelength and again repeat this table. Like this way, you calculate the stopping potential and put it here. Like this
So
way.
that means for every wavelength we have to find stopping potential.
Stopping potential, yes.
Sir, but one doubt.
Hello?
Sir, stopping
So for
potential.
every wavelength we have to find stopping potential.
Yes.
Okay, sir.
Sir, one doubt, sir. For
Yes.
every wave, different wavelength, stopping potential will come same now because it depends on the material, not on the wavelength, no, sir.
No, that two things. One is actually for stopping potential, when you calculate, it depends on frequency. Right? If you change the frequency, then it will be different. Because the energy, that frequency means energy of the light photon, that energy will be different. For different wavelength, the photon energy will be different. So that means if you change the wavelength, that is the frequency, energy has changed. So depending
So he
on
is
what
talking
function
about
of that
threshold
particular
frequency.
what function of that particular material, that amount energy will be lost to release it, and remaining energy will be used for its kinetic energy. So this kinetic energy, with this kinetic energy, it will reach to the other plate, electrode. So now you want to stop. If this kinetic energy is more, then you need more potential to stop it. Point is clear?
Yes, sir. Yes, sir.
Yes, sir.
So then you have to plot it. Then you calculate, that is, this is phi 1 by E. This is phi 2, different material, right? And this slope of this graph, right? And this portion, cut portion, right? This is slope and this is the region, that is V naught, stopping potential. And now here you calculate the intercept and slope. And from the intercept and slope, you need to determine, and from the slope you take the average value, then you calculate h by e equal to that slope, and that is the Planck constant, and determine phi from the different material. For different material, phi will be different. That is the intersect portion, right? That indicates the phi.
So slope is equal to equivalent.
Slope, this is, you have to calculate the slope, right?
H
That
by
is
E.
h by e, right? H by e, and from that h by e, you need to calculate the Planck constant, and you see this is the stopping potential. That is phi. What function of the material? So this cut portion you consider, because it is minus phi. So here it is written in terms of energy, phi by e, right? So that is, you calculate phi 1, that value multiplied by e, right? That value multiplied by e. That is the work function of the material. So like this way you can complete. Now more detailed explanation is given here. I am not interested to go. Now we go to the experiment. This is the experimental link. হ্যালো, হ্যাঁ বলো। হ্যাঁ হ্যাঁ, কোনো অসুবিধা নেই, আমি তো এখন ক্লাস নিচ্ছি, আমি আর যাইনি ডিপার্টমেন্টে, এই বাড়ি থেকেই নিচ্ছি এটা। হ্যাঁ হ্যাঁ ঠিক আছে। কি জন্য? ও ও হ্যাঁ ঠিক ঠিক আছে। হ্যাঁ আচ্ছা 28/6/30। ঠিক আছে ঠিক আছে, আমি ছেলেদের সাথে কথা বলে নেবো ক্লাসটা নেওয়ার পর। ঠিক আছে। Okay, so this is your experimental arrangement. Now you change your material. There are few materials is given here. So we choose copper. Then your plate area, you can change. Okay, switch on the light first, then it will allow you. Right now, we'll low voltage, that is 10 volt. Now you consider the area. So if we change 0.1, 0.2, 0.3 and 0.4, 0.5 up to that, right? So we can consider a particular value, suppose 0.2. Then intensity of the light, that is watt per meter square. We can also change it, right? Suppose for example we consider 10 watt, or we can take 5 watt, or we take it 10 watt, right? Now applied voltage. First, next we change the wavelength. Wavelength is 100 to, you can take 6, okay, 750. Within this wavelength region you can vary, right? And similarly, depending on the wavelength, you can see the color also. It is also changing, right? From violet to almost red, right? So for particular wavelength, we consider maybe we consider 200, right? Now we apply voltage. Now within this voltage, you see 0 volt, and your current is 3.02 microampere. Now we are using 0.1 volt, then 2.82, like this. We are changing our voltage, applied voltage, and you see your current is decreasing continuously, right? Now we have to find out this 0 current. Now for this particular voltage 1.6 minus 1.6 volt, your current is 0. So this 1.6 volt is the stopping potential, right? This is the stopping potential, and wavelength, that is 200 nanometer, right? Now if we at 0 voltage, you see your current is 3.2 microampere. Now if you increase this light intensity, if you increase the light intensity, then what will happen? You see your current is increasing. That means there are more electron is ejecting from the material. More electron is ejecting from the material, and that will be collected by the electrode, and they will contribute in the photocurrent. Point is clear. Now again it will increase more if you increase the area. You see, with the increase of area, the current is also increasing, right? That means when surface area is more, then more photon will be absorbed, and at the same time that release more electron. Point is clear?
Sir,
Yes.
so we have to take exact value or little bit difference can be okay.
No, first you will fix up your area, then you fix up your intensity. After that, you fix your wavelength, right? Then you vary your voltage and note down the current, right? Then when you will get your current is 0, that particular voltage is your stopping potential. And this voltage and corresponding wavelength, that is one sets of data for drawing the graph. Next you change your wavelength, and again you repeat the voltage and current. This table you have to repeat voltage and current, and then you have to again find out the voltage at which the current is 0. That is the stopping potential voltage, and that particular wavelength is another sets of data for graph, right? That is the third table. For third table, right? Like this way, you have to take at least 7-8 value of wavelength and corresponding to stopping potential for a particular material. For example, copper. Then you can calculate the work function of copper, at the same time Planck constant. This is clear?
Okay, sir.
Next, for other material, you change your material and repeat the same things. Then you have to plot the graph, and you calculate the stopping potential and Planck constant. At least for 3 to 4 material you have to consider.
Area of the plate will be constant for all materials, or we can vary this. Sir,
Hello, repeat once.
sir, area of the plate can be constant for all materials, or we have to change it for different
No,
material.
for particular material you fix up the area.
That means for different material we have to select different area plate.
That depends on you. But what will be the change depending on area and intensity, I have already shown you. If you increase the area, then current will increase, right?
Yes, sir.
And if you increase the intensity also, then again current will increase. Okay.
Okay,
So
sir.
yeah, for a particular material, you fix up your area. Then you have to change the wavelength and voltage. For a particular wavelength, you have to change voltage and note down the corresponding current. Like this way. For this table, or you can exclude this table. You don't write this table. Second and third, these two tables you consider, right? for third table, oh, here it is mentioned table 1, table 2. Okay, first table it has not mentioned any table. Now here you can mention your wavelength. Then you come to this table. With the change of voltage, you note down the current. Then when current is 0, that corresponding voltage you put it here. This is one set of data. Then you change your wavelength and repeat this table. And then when current is 0, that particular voltage you put it. And like this way, you fill up this table, and this table is your experimental data to plot the graph. Right? Is it clear?
Okay, sir. Clear, sir.
So now I will share this material, and
So is
then
there any table 3?
Hello?
Is there any table 3?
No, this is actually, there are 3 tables, but here this table has no name, right? It is mentioned table 1 and table 2. That is why I want to mention you that you exclude the first table. Then you consider table 1, that is IV characteristics, and table 2, the stopping potential versus wavelength. This table. And then you have
Sir,
to
we
plot.
have to plot graph for only table 2 or only both table?
No, only table 2. This table 2. This graph is for table 2. For 2 different material, you have to do 2 different table. Table 2 will be, if you do for 2 material, then 2 table. For 3 material, then number of table will be increased, right?
Then sir, page number will be increases.
Yes, page number will also increase. So you consider at least 2 material.
Okay, sir.
Of your own choice. Now I am sharing this, then you can see.
Sir, then the first unnamed table we need not write.
Yes. Don't no need to write first table.
Sir, there is one question. We have to submit this as a PDF or in hard paper?
At present, where you are writing? After completing experiment, you are writing in your hand, or you are considering, or you have present it in soft copy form. That is, you are writing in your computer.
Sir, we are
No, sir, I am writing in my notebook.
Sir, we are writing in like A4 sheets.
Okay,
A4
that
sheet.
is very good. That is very good. For A4 sheet, you have to, I think all of you will return back in the campus. Then you will submit it in hard copy.
Sir,
A4 sheet. A4 sheet you will submit.
Okay, sir. Like we do not need to buy any practical copy and then again write
No. If you buy practical copy from initially, then you can do it. If you don't buy, you have written in A4 sheet, that is obviously okay. Very good. No problem.
Okay, sir.
Okay, sir.
Sir, then we have to take the screenshots, or it will be okay?
Yes, you have to take screenshot.
Sir, but while submitting, we do not have to again, take the printout of the screenshot, right?
That needed. Because if you need to submit, then you have to insert the screenshot, right? Or at the end, if you see the situation is difficult, you cannot submit in hard copy, then you have to take the photograph in your mobile, and you have to make it a PDF file, and in that PDF file you insert the suitable photograph. Then you can make your complete PDF file, and you can submit by email.
Sir, if it is,
So can we submit as PDF?
sir, if it is by PDF, then it is there is no problem. But if we try to submit it in hard copy, then we have to. Can we take the printout in college?
That you can.
Short.
Sir, because in
we are
my
taking
sir,
in,
what is happening now? Because
Sir, if
I
we have to submit in PDF, that
practical
will be
copy
helpful for
in
us.
and in practical.
Okay, that will be decided later on. Now at present you perform the experiment and you write in A4 sheet. That is a very good idea. If it needs to submit in hard copy, there is no problem. We can give another option also. If you have any difficulty for taking printout or screenshot, then that can be considered in soft copy and your write up in hard copy. That we will think about the mode how you will submit. But it is by considering your effort should be minimum and for the benefit of you, that we will consider. But till now, we cannot take any decision at present. What will be the situation? First, you will perform the experiment, then you complete it. Then later on, we will discuss regarding this matter.
Sir, actually one thing, sir, in actually I am writing in practical copy, and in practical copy, sir, all experiments are there. Means physics is also there, chemistry is also there. So, sir, that is why I'm asking, can I submit in soft copy or not? Because then I have to clear the pages then to submit. How will
If you have the hard copy is always welcome. If it is mentioned, you can submit in soft copy. But if you have your hard copy, if you submit hard copy, then it is welcome. No problem.
No, sir. Sir, actually, the thing is, in one book, I'm writing different. Like physics is also there, chemistry is also there. So that is why, like, it is divided. So then, how will I?
That is very bad things what you have done. Uh, if you need to submit in hard copy, then you have to detach those pages from the copy. Then you have to make it pin up all the page. Then you need to submit hard copy. Right. So don't worry about that. What you have done, that maybe later on we'll decide. After that, you have to take the decision.
Yes, sir, because I thought that it will be done in soft copy mode only. So that is why I didn't
No,
pay.
initially I have not mentioned that it is soft copy mode, because if you come here, then there is a possibility to submit it in hard copy. There is a possibility.
So I guess most of the students doing in different pages.
Okay, so that will be discussed later on, but it is not very much difficult that you cannot submit hard copy. If you write in different page or different experiment in same copy, no problem, you will cut down the page and then you can staple it and you can shut down. So it is not the issue. It can be solved. No problem.
স্যার তাহলে কি আমাদের স্ক্রিনশট দিতে হবে?
Yes, at the same time you must take the screenshot during your experiment. That is very much essential. That data will need to verify.
So there is one question. We have a exam on Thursday 6:30. So what is the syllabus for that?
Okay, regarding your exam, it is 15 marks exam. There will be 10 questions. 5 questions of 2 marks, that is 10 marks, and 5 questions each 1 mark. Right? That is
So
5
that
marks.
2 marks question will be
15.
MCQ formed, or we have to write it in pages?
No, there is a multiple choice question. Right? In multiple choice question, you have to give the option will be given. You have to tick which one is correct.
Okay, sir.